Hi everyone, welcome back to QP Learn Online Education. Learn Perfect. Today is one of the new topic, that is applications of Gauss law. In that, the second application we are discussing today. In that second application, what is that second application? That is the electric field intensity due to uniformly charged infinite plane sheet. Okay, so that is our target here. Is also just we have to identify the electric field intensity by applying the Gauss law. Okay, before that, consider a thin plate is a uniformly charged thin plate we have to consider, and then we have to assume one of the Gaussian cylinder. So this is the Gaussian cylinder. So in this cylinder, so we have to point, this is the point, the name of the point is P. At this point, just we have to calculate what is the electric field intensity at this point. Are you clear? At this point, what is the electric field intensity we have to calculate. Okay, so here again in this diagram, again if we have to select the three different parts. Here ds is the surface area. Okay, say I will take, this is the part 1. so this area, this area, that is the part 1, and this area, here top of the cylinder, so that is the part 2, second area. And here is, again this side, right side of this cylinder cap, so this I will consider, this is the part 3. Okay, first we have to select all the three different parts, then we have to apply for Gauss law. Okay, then what we have to do? Apply for Gauss law. See, according to Gauss law, according to Gauss law, you know that in previous problem we done. So Gauss law means the flux, the outward flux is always is equal to the 1 by epsilon naught times of the charge, or q by epsilon naught. So this is the formula of Gauss law. Okay, then what is flux? You know very well. The flux means it is the number of electric field lines passing per unit area is called flux. So that total flux, here in this diagram I selected the three different parts. In the three different parts, the how much of flux is moving outward direction. So that is the total flux. The flux formula is E into ds. Okay, E into ds. So I will write the total flux, that is the E into ds, which is equal to the q by epsilon naught. Are you clear? So this is the flux formula. Flux, it is the product of surface area and electric field line, electric field intensity, or number of electric field lines passing per unit area is called flux. This is the flux formula. This is only, which represents only magnitude. If you want the direction along with this, means cos theta we have to add in that formula. That is, if you add, so suppose E into ds, the cos theta means that is including direction which represents. Are you clear? So this one. Then this one this is the total flux. Total means part first plus part second plus part third is equals to total. Now I will write separately. So integration for the part first one, E into, so ds, the cos theta. Second part plus second one, that is second part, at second part E into ds, the cos theta. So second part. Then third part, this is the third part. Okay, your third part E into ds, the cos theta, which is equal to, here as it is you write, that is the q divided by epsilon naught. Then you decide the angle. See, for example, I selected in first area the field direction, here the charge, this plate is uniformly charged, means this charge, the electric field direction will be like this. Are you clear? The electric field direction is like that, and this area direction is also like that. See, both are in same direction. The angle between the electric field direction and area, this area direction is in same direction, so that angle will be 0 degree. Same thing in this side is also, in this side the field direction is like that, area direction is also like this, so that both are in the same direction. Part 3 is also 0 degree. Angle between these two is also 0 degree. If you go for part 2, it is the upper portion like this area. So here the field direction is like this and area is showing upward direction. Area is upward, angle between these two is 90 degree. Okay, just all the degrees you substitute in this equation, so you will get some simplification. I will write now. So that is integration of the E into ds, the cos, first one is, what is the angle? Cos 0 degree. Okay, then second one, E into, this is the second part, E into ds, again cos, second is how much? Second is 90. Okay, 90 degree. Okay, plus then third part, E into ds, the cos 0 degree, 0 degree. So third part is 0 degree. Clear? So then, which is exactly, so which is equal to the Q by epsilon naught. Then you know that the cos 0 degree is always 1 and cos 90 degree is equal to 0. It means, are you clear? This term, the cos 90 term, this term will become 0. Cos 90 is 0, 0 into something is 0, so that this term will be eliminated. And here cos 0 means this will become 1, and here is also 1, 1 into E into ds. Are you clear? Now I will write part first, what is left? Integration of E into ds, because cos 0 is 1, so 1 into this is 1, plus E into this is the what? This is the third part. This is the third part. Here this is also 1. E into ds is left. E into ds, sorry, E into ds, which is equal to so Q by epsilon naught. Now you take the E outside. See here, E is outside, the ds is inside. Same way here is also E, you take it outside, integration of ds, which is equal to the Q by epsilon naught. Then here integration of ds is yes, here integration of ds is also yes. Now I will write here, so E yes plus E into yes, which is exactly equal to the Q by epsilon naught. Are you clear? Here ES and ES, so total 1 ES and 1 ES, so this is 2 ES is equal to the Q by epsilon naught. Okay, let it be equation 1 now. Okay, now you take, now we have to go for to calculate this charge. Okay, now see, charge, here charge means here what type of charge density we can observe. See, I told you in a previous slide also, the first one is linear charge density, that is lambda is equal to, the lambda is the linear charge density is equal to charge divided by L. This is the linear charge density. Same way, sigma is equal to charge divided by surface area, that is surface charge density. Next, the rho is equal to charge divided by volume, that is called volume charge density. In previous we applied this one. Now because this is the plate is the thin plate, the plate is having the surface area, so that we have to apply this one. So I will consider this one. Now the sigma is equal to the Q by S. I want Q outside because you take Q outside, so Q which is equal to sigma S. Okay, now substitute this sigma S in this equation in the place of Q. Okay, so 2Es is equal to, in the place of charge just you substitute sigma S divided by epsilon naught. Here this S and this S is cancelled, so our target is E, so that E you take it outside. E is equal to here sigma divided by this 2 you send this side, so that is E 2 into epsilon naught. So this is the final answer for our final derivation of this electric field intensity due to uniformly charged infinite plane sheet. So this is the final answer. I think you all understood very well. Okay. Okay, in next class I will take third application, that is electric field intensity due to uniformly charged sphere I will take. So until then, bye bye, and thank you for watching this video. Have a nice day.